Hello everyone, this is Mathematics and we are here with the first section of the first chapter of Pure Mathematics 1 Edexcel International A-Level Mathematics. In this chapter, algebraic expressions, we're gonna have to deal with different methods that you have worked with before when in IGCSE mathematics. You're gonna be familiar with these, so there are no worries for that. And these are just a revision of whatever you studied algebraically in IGCSE to make sure that you are ready to go to the next chapters. So you're gonna need this chapter a lot because you're gonna use it very frequently in the following chapters. So maybe in the exam, there is not a specific question for you to ask algebraic expressions, but you're going to use it in whatever questions that you have. So, algebraic expressions, laws of indices, first section of the first chapter. So, let's get started. Laws of indices. Okay, all right. So, let me switch the pen color to dark blue. All right. So, the first law, second law, third law, and fourth law. Okay, what does the first law say? The first law says that a to the power of n times a to the power of n is equal to a to the power of n plus n. So what does this mean? This means that, okay, we simply know that a to the power of n means a times a times a times blah 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 times a. How many times? N times. So, if I give you an example for the first law, you're gonna see that, okay, so let's say 2 to the power of 2 times 2 to the power of 3. We know that this is 4, we know that this is 8. 4 times 8 is equal to 32. However, with our laws of indices, we know that this is 2 to the power of 5, which is also 32. So, this is how it applies to the examples and to the numbers. So variables x, y, u, v, whatever variable that might come to your mind, they are just representations of numbers. They are variables. They can take any value, but they are still numbers. So the same law for numbers applies to the variables. So it's alright. Second law, a to the power of m divided by a to the power of n is gonna be equal to a to the power of m minus n. Okay, why? A little further in this chapter, we're gonna know that, okay, a to the power of minus n is gonna be equal to 1 over a to the power of n. And so, I'm gonna look at the second law again. A to the power of n divided by a to the power of n. Okay, if I have a division, in order to make it a multiplication, I have to get the reciprocal of the second term after the division symbol. So what do I mean? A to the power of m times 1 over a to the power of n. This is how we do it, right? This was how we did it in IGCSE. So it's gonna remain the same. Nothing's gonna change. So, and as I mentioned here, this, no, okay, this can be just represented like this. So I can write it as a to the power of m times a to the power of minus n, which with the first rule, okay, let's have a look at the first rule again. First rule, I know that this is gonna be a to the power of m minus n, right? Oh no, not time for the warning now. So this is for the second law. And guys, just for you to remember this, I'm gonna mention it once again. For these first two laws, the law of addition of the indices and the law of subtraction of the indices, the bases need to be the same. Bases need to be the same. A to the power of m times a to the power of n have different exponents, different powers, different indices, doesn't matter which term you use. They have different, let's say, exponents, but they have the same base. And so the result of the multiplication, the division, it's gonna have the same base as well. The power is the only thing that is gonna change. So put that in mind and just don't forget it at all. So let's go to the third law. So for the third law, if I have a to the power of m in brackets to the power of n, then it's gonna be a to the power of mn. So okay, let's give it a try with numbers. 2 to the power of 2 to the power of 2. So as I know, as for laws of indices, it's gonna be 8. Why did I use 8? Okay, 2 to the power of 4, right? But let's just do it normally. 2 to the power of 2 is 4. So I write 4 to the power of 2. What is 4 to the power of 2? 64. Thank you so much. Oh no. Why did I write 4 to the power of 3? Okay, 4 to the power of 2, 16. I'm sorry. And 2 to the power of 4, again 16. So these two are the same. AB to the power of m, fourth law. AB to the power of m is gonna be equal to a to the power of m times b to the power of m. So how does it apply to numbers? Guys, if I write 6 to the power of 3, what is 6 in prime factors? 2 times 3. So it's gonna be to the power of 3 again, right? This is the same. But I can expand these brackets. Why? Because here it is multiplication. Wait, what did you do? Why did you delete this one? Okay. So it's gonna be 2 to the power of 3 times 3 to the power of 3. We know that 6 to the power of 3 is gonna be equal to 216. And so 2 to the power of 3 is gonna be equal to 8, 3 to the power of 3 is gonna be equal to 27, and again it's gonna be equal to 206. Right. So this is all about the laws of indices, or rather say the first section. And here remains two little warnings. The first warning: a plus b to the power of n does not follow the same rules for ab to the power of n. Right, because sometimes we see some people do it like that. Okay, they say that if a plus b, I have a plus b to the power of n, then it is gonna be a to the power of n plus b to the power of n as well. Like they might not do this. They might not do this very often, but in the process of reverting this back, like they have x to the power of 2 plus y to the power of 2. They just simply write it as x plus y to the power of 2. This is completely wrong, my friend. And so, be careful about this one, because this is completely wrong and we do not accept this. However, if I have a b to the power of n, then it's gonna simply be a to the power of n times b to the power of n, and the rule is applied. Okay, let me erase this. Right. Okay, next warning here. So, warning: fraction of 4 a over b plus c does not follow the same rules for a plus b over c. Right. Why? Because a over b plus c cannot be written as a over b plus a over c. This is completely wrong. However, a plus b over c can be simply written as a over c plus b over c. This one's true. That one's wrong. So I don't want to waste your time. You might know this, so I do not write any example for it, but you can do it with just some examples. If you cannot just get it by theory, by getting it by theory, I mean some people just want to try it out, just want to make sure that this rule applies. So you can do it. And for the time of the video to be as short as possible and just to save your time, I will end the video right now. And so see you in the next session, guys.